If the Earth is curved, then the further away that we look out to sea and the further away these islands are, then we should see these shorelines becoming more and more hidden by water as the islands drop away and hide behind this alleged curve of the Earth. And as you can see, this Nikon P900 is approximately 6 feet above the water level. Let's now zoom in on the island of Skorva, 5 miles away. You can see central to your picture, and the curve of the Earth, according to the GitHub curvature calculator site, should mean the coastline of Skorva should be part obscured by approximately 2.5 feet of water at 5 miles distance. So let's now zoom in. Here comes the coastline into view, and as we can see quite clearly, there is no 2.5 foot drop. We can see right clearly all the way across. We can see the water's edge, we can see where the dark is, where the wet of the tide just wetting the bottom of the stones. Pan across. Quite clearly there is no 2.5 foot drop. For the same 5 miles distance, Adam Hellman's calculator at cohp.com predicts that there would be a 16.5 foot drop at 5 miles distance. And we'll now go to the island to the left of Skorva, which is Lillmulla. And Lillmulla is, according to the As the Crow Flies site, 6 miles from where this camera is. The GitHub curvature calculator tells us there should be a drop of 6 foot. And Adam Hellman site calculates there should be a drop of some 24 feet over the same distance. So let's now move into the Lillmulla island, go right to the shoreline, and once again guys, we can see at 6 miles we can see the shoreline quite clearly. There is no 6 foot drop according to GitHub, and there is definitely no 24 foot wall of water obscuring this coastline. 6 miles away, again absolutely nil earth curvature proven at this point. So let's zoom back out, and the third island that we're going to visit is Sturumulla, which is 8.5 miles away. Again, these distances calculated by asthecrowflies.com. GitHub tells us that at 8 miles distance, this island's now in the centre of your screen. The island should have dropped 20 feet because of the curve of the Earth, which means there should be a 20 foot wall of water obscuring the shorefront at Sturumulla. So let's zoom in guys. You won't be surprised to see this is just an exercise in futility. 2 lovely little boats there skipping across the top of the sea right the way into the shoreline, 8.5 miles distance, and you can see quite clearly where the wet of the tide is watering the edge where the rocks meet the sea. So I think we can confidently say guys that at this stage, 5, 6 and 8.5 miles, there is no observable curvature to the Earth. I think what we need to do now guys is crank up the distance and focus on the last island and pan to the right of Skorva, and turn our attention to the island of Engeloya, which is some 21 miles away. Now GitHub tells us there should be a wall of water of some 216 feet obscuring the shoreline of Engeloya, and Adam Hellman calculates that there's a 294 foot wall of water in the way of what we should be seeing, which is equivalent to 89.6112 metres for all you metric buffs. What I'll try and do is maybe focus on a rocky outcrop, and then if I get focus on that, I'll zoom down to the shoreline. Okay, we got focus, let's go down. Oh guys, as far as I'm concerned, there's no 300-foot wall of water obscuring the view there. Everything that we're looking at, guys, is totally flat. I don't know about you, but I just love it. I just love this practical experimentation. Boats that with a normal eye, with no telescope or no zoom lens, we'd be thinking, oh, look at that boat there. Look, you see it disappearing? That's because of the curve of the earth. Actually, no. When we have a powerful enough tool to zoom in, come back in, lock in on the boat, and we can see it quite clearly. There is no curvature. There is the hull of the boat. A beautiful sight to behold. So if you're a ball earth believer watching this video right now, I hope it's starting to sink in that the maths that you're using to explain your ball earth model and the model itself, they just fall apart in the light of simple real life experimentation. I think you suffered a fatal blow in this video, and I don't think